Hello students, welcome to this topic called as the Bayesian network. So in our previous class, we have seen what is probability, the simple definition of probability, concept of probability, right? So the joint distribution, joint probability, conditional probability, Bayesian theorem. So Bayesian theorem is one of the very important concept because once you have understood the Bayesian theorem, so now it is very easy for us to look into the next topic or the topic what we are going to discuss today, which is called as the Bayesian network. So now let us try to look into this particular concept. What do you mean by a Bayesian network, or why this particular Bayesian network is very important for us? So Bayesian network has been one of the very important topic and a contribution in the field of AI for the past 10 years. So now it provides a way to represent the knowledge in an uncertain domain. So already, because the topic what we have started discussing from quite few classes is about the uncertainty knowledge. So we are talking about the knowledge which is incomplete, the knowledge which keeps on changing, which you cannot predict, right? So that is what we are going to call it as uncertain knowledge. So when you have got an uncertain knowledge, so one of the best way in AI to do the reasoning is by using the Bayesian network. And you have to remember, so this particular Bayesian network, it completely depends upon your Bayes theorem and probability concepts what we have discussed in our previous class. Now as you can see here, a Bayesian network, or it's also called as the belief network. Now, it is a probabilistic graphical model that represents a set of variables and their probability independency. Right? So it is a graphical model. Now, just like our belief network or the semantic network, now here also, now you are going to represent it with a diagram. So we are going to represent it with a graph, like a diagram which consists of nodes, right? So now which consists of nodes. So you can see here a Bayesian network consists of set of nodes and some set of directed edges between the nodes. So we'll be having the nodes and we have got some directed edges, and each node is associated with some probabilities. That is, like, say, nodes is nothing but what the events whatever is happening in our particular example. Now say for example, now if you are considering the symptoms and the diseases, now how the doctor is going to predict based on certain symptoms, right, what the disease the patient is suffering. He is going to do the diagnosis based on the symptoms. So now that symptoms and the diseases, now all this can be constructed using a network which is called as a Bayesian network, and for every symptom, now there will be some probability associated with that. That is what we are going to consider in this particular networks. So now when we are talking about Bayesian network, this is the formally we can define the Bayesian network as follows. A Bayesian network, now it is a graphical way in which you are going to represent the probability of a particular events, right? The probability, so it's also termed as the probabilistic graphical modeling technique that is used to compute the uncertainty by using the concept of probabilities. Now this is like a simple diagram what you can see. Now you will be having some nodes and each nodes is connected with some link. Now when we are going to construct a Bayesian network, one thing you have to remember, very important thing, is that the network what we are going to use, the diagram what we are going to draw, it is having called as a DAG. So it is a directed acyclic graph or DAG model. It models the uncertainty of an event occurring based on the conditional probabilities, or we can say conditional probability distribution of each random variable. Right? So here it consists of a directed acyclic graph. So there is no cycle here, it is a DAG graph whenever we are going to construct a Bayesian network. So what do you mean by directed acyclic graph? Already you might be studied it in your previous semester. A DAG or directed acyclic graph. Now it is used to represent a Bayesian network, and it is like any other statistical network or a graph or a diagram. Now it consists of some set of nodes and links. So where link denote the relationship between the nodes. Now when you are having these nodes, now what type of usually the probabilities you are going to associate with these nodes? Now either you will be having a joint probability, or you will be talking about a conditional probability, or sometimes depending upon our examples, now even some events may be there which is completely independent from the other. So you know already the definitions of the joint probability. So probability of A intersection B. Now it is just like you are going to consider the probability of two events which is occurring, both are happening at the same time. We call joint probabilities. And conditional probability, so we say that probability of A given B, that is the probability of occurrence of an event A given that the event B has occurred, is called as the joint probability. Now these are the two probabilities which you are going to associate with our Bayesian network. Now when you are talking about the semantic of a Bayesian network, now what it consists of? Now as we already said that there are two ways to view our Bayes net: a representation of a joint probability distribution and a collection of conditional independent statements or the events we are going to have, right? So now let us take an example. Now it will be more clear for us to understand now how we are going to construct a Bayesian network. Now this is a very standard and very famous example called as alarm system. Now say for example a particular person, now he has implemented an alarm system in his house to identify that whenever there is a burglary means a thief happens or some thief comes, and if a robbery happens in his house, to identify that particular thing, now he has installed an alarm system. Right now he has installed an alarm system. Now this alarm system is going to give the alarm on two conditions: one, whenever there is a theft or whenever there is a robbery happens in this particular house, so the alarm is going to make a sound, or if there is an earthquake. Suppose if there is an earthquake also, the alarm is going to make a sound or it is going to ring the bell. Now say for example, now you have installed this in your home and there are two neighbors nearby your home or next to your home. So one is called as the Mary and the other one is called as the John, and both of these don't know each other, but they are the neighbors. So now you have informed both the Mary and John to call you and inform that whenever the alarm in your home is ringing, they have to call you, as you will be out of station or you are working in your office. So if the alarm rings, they are going to make a call. Now there is a twist here. Now when we are talking about this Mary and John, so now let us take that one particular person, Mary. Now the Mary cannot identify the difference between the phone ringing and alarm ringing. Right now it happens that if the phone also rings, now she might think that alarm has ringing and she may call you and inform that the alarm, that is your alarm system in your home, is ringing, right? So there is a confusion for Mary. Similarly, when you are talking about another particular person, John, now what his problem is that now he has got a habit of putting music system. Now if he has put the music system in his home very loudly, the songs or the music, he cannot listen the alarm if alarm rings, right? So if the alarm in your home is ringing because of either the earthquake or there is a robbery, now if the John's music system is on, he cannot listen to the alarm and he cannot make a call. So what we are going to say is that now there is no complete guarantee that these two people will make a call and tell you that the alarm is ringing. So now we want to we want to draw all these things in a network which is called a semantic network. Now if you look into this particular diagram, now you can see here, now we have got an alarm ringing. So now this alarm is ringing here, or this alarm will ring whenever there is a burglary or whenever there is a robbery or there is an earthquake. That means this event alarm, it depends on these two factors, right? So when there is an earthquake also, this system will give a signal or alarm will happen, or when there is a robbery also, alarm will happen. And if alarm happens, now there are two neighbors, right? Now because those two, you have informed these two persons. Now if alarm happens, either John may make a call and inform you, or Mary may make a call and inform you, or both can make a call and inform you, depends upon the at that particular moment of time. Now this is how we draw a semantic network, right? So we have an alarm system. If there is a robbery or there is an earthquake, the alarm system will become active, and once it starts ringing, now you have informed two neighbors, now they will make a call and tell you that what has happened, right? So now when you look into that diagram, we call it as a directed acyclic graph. right? So the nodes, these nodes are random variables which can be either discrete or continuous. Now in here in our case we are talking about the discrete variables. So if there is a robbery, so now the alarm is going to ring. So and this arrow mark or the directed mark, it indicates that this node alarm, it depends on both these factors. So it depends on both of this particular factor. So an arrow from node X to node Y means that X has a direct influence on Y. So we can say that X has an influence on this particular Y. So now let us take this the example. Now when you are talking about our example, so which has got now two parameters. Now already we told that our Bayesian network is just a pictorial representation or a diagram which has got some probability. Now what is that? That is the second thing. One is you have got a directed acyclic graph, and the second one is the set of parameters. Now what is this set of parameters? Now this set of parameters are nothing but the probability associated, right? So it is the probability associated. So now we will try to understand this. Now say for example B, burglary happening or robbery happening. If this event is, if you are going to call it as B, what is the probability? P of B is the probability. Now we have two things, right? First we will look into the true. So 0.001, that means what is the probability that there is a robbery or burglary? So it is 0.001. That is true, right? The P of B. So if the probability of burglary happening is 0.001, then what is the probability that event is not happening? 1 minus of that, that is 0.999. That is what is written in this particular table here. Similarly, what is the probability that an earthquake will happen? So what is that probability? 0.002. If 0.002 is the probability of earthquake happening, then what is the probability that earthquake does not happen? 1 minus of that, that is 0.998. So that is termed as false here in this particular table. Now if you consider, if it is known or if it is given for us, what is the probability of this event B and the probability of this event E, so then when the alarm is going to ring, when this particular alarm is going to ring, that is the probability of this particular event A, alarm A you can identify, or it is written as A, denoted as A. So probability of occurrence of this event A or the probability of alarm ringing now depends on B and E. So you can see here how the notations have been given. The probability of an occurrence of an event A given B has occurred, conditional probability. Now we are bringing that conditional probability here. The probability of alarm is going to happen, so the alarm will ring given that robbery has happened or given that earthquake has happened, right? Now this set of parameters is being associated. Clear? Now it is more clear. Now let us take a look into this particular diagram here. Now there is a burglary is going to happen. So we are given probability of B. What is this probability of B? Probability of B is 0.001. If you know probability of an event B, you can find the probability when this event does not happens, when there is no burglary. That is 1 minus of this, which is 0.999. Similarly, probability of an earthquake is given. What is the probability of an earthquake? 0.002. The probability of earthquake is 0.002, means the probability of earthquake not happening, false, is 0.998. Now when you consider this alarm, now when this alarm is going to ring, it depends on either B or E, conditional probability. The alarm will only ring, right? Alarm will only ring if there is a burglary happening, if there is a robbery. That is probability of B. So probability of occurrence of this event A or alarm, given that B has occurred, given that there is a robbery, what is the chances? Similarly, or if there is an earthquake also, the alarm will ring. So now here, now we talk of our conditional probabilities. Now that is given in this particular table, right? Now here you have to just look into this true. right? Now if you look here, what is the probability of occurrence of this event A given that B has occurred? Given that B has occurred. Similarly, if you know that B has occurred, then you can find 1 minus of that, that is not occurring. Now, this is the table which you can construct for this particular joint probability distribution. Now, if you go for John calling, so when John is going to call you and inform that an alarm has happened, so that is given as probability of John given that alarm is ringing, which is denoted as P of J given A. Similarly, probability of Mary calling given that alarm has, that is this event has occurred. So again this is represented as conditional probability, right? Now this, if you look, all this data is given for us. Now if you look here, now when you consider this event robbery or burglary, now probability of B, that is it is given 0.001. Now when you are having this, you can find this also, 1 minus of this, which is false, that is it is not happening. Similarly, probability of an earthquake is given 0.002 and probability of earthquake not happening is 0.998. Now all these things are given in the previous slide, it was given in one particular table, that's all, don't get confused here. Similarly, this is the conditional probability of occurrence of an alarm. So now you can see here there are two events here. One is B and the other one is earthquake E. So the probability of alarm bell ringing given A, that means given, that is given B has occurred, right? So now B is true. Both when there is a robbery and E, when there is an earthquake, both will be true, because here we have two events. So two events means four variables you are going to get. So based on that, so when there is a robbery, we can say it as true, and there is no earthquake, then this will be false. So one will be true, one is false. Since any one is true, alarm will ring. So now here you can go to the second row here. Two, true and false. Now what is the given probability? The probability is 0.94. Right? So now we can try to extract, or you can say the joint probabilities of all these events when both are been occurring. Now, similarly, the probability of this particular event. So, when the John is going to make a call, only when alarm rings. So, he is going to make a call. Now, again, that how much is that percentage? The probability is given that when the alarm rings, 0.90% he is going to make a call, but 0.1% he may not call, because there is a chances that he may he might get confused with the music system. If John in his house, if he has played a music system very loudly, then he cannot listen this alarm, so he may not call. So chances are there. Similarly, when the Mary is going to make a call. So this is how we are going to construct a, what is this, semantic network. The same thing is been explained here. So when we are considering this particular B and E, so now true, now for a given combination of values of the parent class, that is B and an earthquake E. So now we are going to make an entry. So the probability of alarm ringing A is equal to true given that B comma E. So given that B comma E. Now when you say that two events B and E, now since two events are there, now there are four variables. But right, so you will be having four variables. Now similarly here for probability of alarm not ringing, false, given that B comma E, may, again it also is going to add up. So when all those things, now we are going to construct a table here, so which has got 8 values. Right? So now this is how the conditional distributions are been happening, and we can try to answer the question. Now let us take the same example. Now these are the data which is given for us. Now if you look here, the probability is given, which is 0.001 when the robbery is going to happen. Probability of an earthquake is given, the joint probability of when this alarm is going to happen. So now these values are given for us. right? So when both the events are true, that means a robbery also happens simultaneously, earthquake is also there. When both event happens, the chances is 0.98 probability. So B is happening, earthquake is false, then 0.94. Similarly, B is false and E is true, 0.29, and both are false, 0.01. And when John is going to make a call. So when there is an alarm, chances is 0.90. When there is no alarm, chances is 0.05. Similarly, these data are given for us. Now what we are going to reason, Bayesian reasoning, how it happens. Now what is the probability that the alarm has sounded? Alarm has ringed, but neither a burglary nor a earthquake has occurred. That means there is an either robbery has happened, neither there is an earthquake, but the alarm has sounded, and both John and Mary has called. So both have called you and told you that alarm has happened, but actually in reality neither there was a robbery nor there was a earthquake. Now what is that probability, what is that chance that this will happen? So we are going to find this. Now how do we write this? Now we can write it as probability of C here. Now you can see from this problem, now both John and Mary is going to make a call. So the probability of John and M, they are going to make a call, and A. What is this A? Alarm has sounded, right? So and negation B. Negation, why negation B? Because there is no burglary, there is no robbery. It is given in our problem. Neither a burglary nor an earthquake has occurred. So negation B and negation E equal to. So you have to find the probability of this. Probability of J and B, M and A and negation B and negation E, which is equal to. Now we are going to apply the joint probabilities. We will take one event. First we will take this event J. Now when you look into this event J or John calls, it depends on this alarm. Right? This event depends on this particular alarm. John will make a call only when alarm rings. Right? So now probability of J given that A has occurred. Given that A has occurred into next one. Next event is M. When Mary is going to make a call, only when alarm occurs. So probability of M given that A has occurred. Next event is our alarm ringing A, the third one, into probability of A. Now if you look into this diagram, when the alarm will ring depends on this event B and depends on event A also. Both has to be taken into consideration. So the probability of this event A given that, now what is given? What is given? Look into a problem. Neither burglar nor an earthquake. So both has not occurred. So probability of A given that negation B comma negation E, right, into what is the next one? Negation of B. So probability of negation B into probability of negation E. Now if you look into this event, these two event, it does not depends on any other event. So only one event is there. So probability of negation B into probability of negation E. So this is the equation. Now is equal to, now these values already is present. All the values are there with us. Now say for example, the probability of J given A. A has occurred. Now from this particular table we can get the John is going to call, right? When John is going to call, given the alarm as C here, the probability of J means John is calling, given that A has occurred, that means alarm has ringing. So alarm is ringing true. What is the probability given for us? 0.90. So you take this probability 0.90. The next one, probability of M given A. So probability of M given A is 0.70. Take it. The third one, probability of A, alarm, given that negation B, comma negation E. Negation B means what? It is false. Negation E is also false. When both are false, when this alarm is going to ring, what is the probability? From this table, if you look, when both the events are false, what is the probability? Probability 0.001. Get this value. Similarly, the next one, probability of negation B. If this is the probability of B, 0.001, what is the negation B is 1 minus of that, which is 0.999. Similarly, for this negation is that 0.998. So now when you multiply, now this is your answer. Now what is this? 0.00062. This is the probability that the alarm has sounded, but neither a robbery has happened nor an earthquake has happened, but both the neighbors have called and informed you. Clear? Now this is the example, and this is how the Bayesian the system is going to work. The Bayesian network we are going to draw. This is a very simple and very small concept. So, and this very important concepts is like this. Now, what the examples where the uncertainties are there. Now we can try to construct a Bayesian network. Now, which has it is just like an directed acyclic graph, and probabilities are assigned to that particular graph. Clear? So hope that you have understood this particular concept. Very simple concept. Hope that you have understood that. So thank you for viewing this particular class or the video. Have a nice day. Bye bye.